I was having a wee think about, you know, what I'm going to take to the geek meetup in Wellington, and I think I've decided that it's potentially going to be HP. It's going to be like handhelds, but the core of it, I think, is going to be the HP calculator collection. Not the entire collection, but just like a core of my collection. And that starts with the HP41, the famous HP41, which you can see right here. And this particular calculator is my daily driver. I use it every day. It sits on my desk beside me, and I can just reach over and start using it. It's great. And I know that I've got a computer sitting right in front of me as well, but it's just so much more convenient to reach over and grab a calculator and start punching away on the keyboard, which is a wonderful keyboard as well because of the amazing tactile feedback of these keys. And the other big advantage for me, and I'm guaranteeing that for a lot of people that use these HP calculators, is the reverse Polish notation, which differs to your normal calculator like you find on a Casio or something like that, which is algebraic notation, and it's a bit different, but it's got to the point now where I can hardly use an algebraic notation calculator now. I'm so used to RPN, and it's just so good that I struggle to go back. I used algebraic notation calculators at school, and this type of calculator I started using when I was at school as well, but not at school because my dad had one of these calculators, and of course that was like a treasured, expensive calculator that I wasn't allowed to take to school. If I had I'm sure it would have blown a lot of people away, all the maths nerds anyway. But I think my maths teacher, she would have been impressed. Yeah, so I thought I'd just go through some of the basics with this calculator, just to give you an idea of the look and the feel, and maybe even we could go through some reverse Polish notation. And I've got another calculator here which will make it a little bit easier. This one here, potentially because of its display, will make it a little bit easier to demonstrate the reverse Polish notation. And so what we can see here is the basic operations manual, and there's another manual, second manual. There's this one here, information in detail, and this manual won awards back in the day, and you'll see why. It's just such a pleasure to go through. Everything's explained. It doesn't leave any question marks whatsoever. You never feel as though you need to ask someone what's going on. It's just so good. It's so amazing. I can see why it won awards. These calculators flew on the space shuttle, and so they were used as backup, from my understanding, for navigation and all sorts of other tasks that you might need to do on a space shuttle. I don't know specifically what they would have been, but yeah, there are photos of them being used on the space shuttle. So yeah, I just thought I'd make a little start and sort of introduce people to what they're all about. So it's basically going through right from ground level, like you know absolutely nothing about these. And so it's talking there about the store command. Black key box is a primary keyboard function, like store, like this, that one there, store. And then you've got the gold key box, which is a shifted function. So likes of you hit the shift and like 10 to the power of x, that one there, shift that. Date, blue key box for alpha use if you execute followed by the alpha name. So what you can do is, because this is an alphanumeric calculator, some people call it a computer. You know, you've got your standard calculator input there, but you've also got an alpha section there just by hitting the alpha key up here. And if I I can execute a command, for instance, like hit the execute key, go into the alpha mode and type date, and we get a date which is incorrect because I haven't set it. Okay, so I think that's saying that it's the 6th of the 10th. It's probably an American format. I think you can change that as well. 6th of the 10th, 2001, and it's a Monday. So, you know, you can do that. And then if you just go back to alpha, you can type in just your alpha keys, just like that. And there's a specific amount of alpha keys or characters that you can fit on a line as such. But you'll notice that because even if I LMNOP, you know, if I put the full alphabet in here, I'll do that again. You know, like it's scrolling off to the right there now. I go out of alpha back to numeric. You know, numeric here. If I go to alpha, it will scroll across the full display of whatever you've got sitting in the alpha register. And so yeah, it uses registers and whatnot. So yeah, so that's the blue letters, alpha characters 1, 2, 3. You know, the gold characters. That's these ones. Like that. Black letters and key boxes, special functions, not alpha. Okay, but that will become more apparent later as we carry on there. I won't go through every single item in there, but you've got a really good, you know, it's like a index. Is it an index? Contents. So yeah, pretty comprehensive list of diagrams and tables. Operations in detail. So this is like showing you what the different parts are, appendices, where to start. So this, because this is not the very first of the 41C calculators released, this is the 41 this is the 41CX. You can see down here, it'll be a little bit out of focus because I've got fixed focus set here. But the very first one was just the HP41C, not the CX. So the 41C, it had a very nice manual also, but it was just one volume. I've got the original here. Nice, very nice spiral bound manual, and you know, just the best of quality. Yeah, just absolutely oozing quality. Just amazing. The fold out sections there, really nice. And so the very first, the HP41C, that calculator there, that came out with just the one manual, but for the later manuals they split them up, split it in two manuals. So you've got the basic operations, which we're looking at right now, and then the in-depth, more in-depth one comes later. So really this is just a flow chart to say, you know, how much do you know anything at all? If you know nothing, you start with the basic operations. Okay, so, you know, this, you can pause at any time, I guess, and watch this later if you want, read this later if you want to. Okay. So you've got, it's going to show us the keyboard overview. So basically just going through the on-off switch, pretty straightforward, nice and easy. User we won't go into. There's a programming, you can program these, so pretty comprehensive programming mode, and you've seen the alpha mode there already. And you know, you've got enunciators here for the shift key. If I toggle shift there, you can see the shift enunciator coming on and off. Go to the program, there's a program enunciator and alpha there. So pretty clear. Try not to bump the tripod too often. Sort of having to reach around it. It's a little bit awkward, but hopefully I don't bump things too much there. If I want to clear the register, so like some in the alpha register here, if I want to clear it, I can hit the backspace and it will clear the register. If I shift clear X, clear A, so that's clear X/A, so that's clear the X register or clear the A register. It clears the whole lot. So actually, but similar to just backspace basically. But if I'm in the enter mode and I just type in some A's, I can use this back arrow to just go back one step at a time, you know, for editing. And so, yeah, primary functions are on the top face. These keys are kind of, they're sort of beveled, flip side on. You can see they're beveled at the front, and they're very nice tactile feedback. And so the top of the key is your primary function, you know, like change sign or store, recall, cosine, sine, tangent, all that sort of stuff. That's on the front face of the key. And then you've got the alternate function was like your shift beep, things like that. What else is it talking about there? Yeah, that's pretty much it for that. Through the keyboard stuff. Execution mode is basically just, as you see it here, is like, you know, 5, enter, 8, multiply those two together. That's just your execution mode, and then you've got a program mode which you can store programs and run them. It's basically going through all the nitty-gritty there, but you know, I'll go through it anyway. And so a lot of that I can explain as we go. So there's an example there. If you want to perform an operation that uses only one number, like sign, you don't need to use enter. And the enter key is very important in an RPN calculator scenario, which we'll see. And so if you want to calculate 15 minus 3, you first of all you put in 15, so you enter 15 like that. And so I mean, you can carry on adding numbers, you know, here, but if we just want to do 15 minus 3, we type 15 enter, so that's now entered. And then you want to subtract 3, so you hit 3, and then you do the operator that you want to do, which is minus, and that gives you the answer of 12. So quite different to, you wouldn't do 15 minus, you can see that's wrong already, 3. There is no equals. Well, there is in alpha mode, but it's really only an equals for display. You see it in blue just there on the 2 key. That is literally just for display. That means nothing. That equals in this direct enter mode. Like if I clear everything, right, and I do 15 minus, it's actually taken -3, which I think was in one of the registers, and then subtracted 15 from it. So yeah, it just, if you try and use it like an algebraic calculator, it's just going to go wrong badly. And so if you want to find this sign of 0, you know, enter 0. You type, when I say enter it, you just type it in. You don't have to hit enter. You just type it and hit sign, and it will show you the result. And so if you want to find lots of the square root of 45, this is your square root key up here, and so you just type 45. You don't have to enter, you just hit square root. Yeah, just talking about change sign. Change sign is pretty straightforward. Just hit change sign. Can't see it for looking. Right there. Just adds a negative to the start of it. Exponents. You can do enter exponents nice and easily. Pi. There is the pi key down here. Shift 0. Gives you pi, and you'll notice that it's displaying 2 decimal places, which will be rounded up. If I want to display 4, I can just run the fix command, so that's the fix, so shift 1, and if I fix that's 4 decimal places, yeah. Okay. So here it's introducing us to the registers, oh, sorry, the stack. So memory stack, automatic memory stack makes it possible to do long calculations without using parentheses or storing intermediate results. It's because the computer, using its own memory stack, stores and recalls previous or intermediate results, which you can then use in subsequent calculations. The memory stack is 4 registers high, labelled as shown below, so I'll get to that. It holds your current and most recent entries. Generally, it is the contents of the X register that you see displayed. So what you see there is pi 3.1416. That is currently in the X register. When you press enter or key in another number following an operation, the number in the X register gets pushed up into the Y register. The contents of the Y, Z, and T registers also move up one level. The number that was in the T register is then lost off the top of the stack. So the stack is what determines how many intermediate results the computer can hold in the course of calculation. So it can retain 4 numbers. As you execute operations, the stack generally drops as 2 numbers are replaced by 1 result. And that's actually quite easy, a lot easier to see in action on this other calculator, which I can bring in just to clarify that. So they don't explain it in detail, but they just mention that learning the stack, understanding the logic operation of the computer. Okay. So the enter key is used only for separating the sequential entry of 2 numbers. So calculation, for instance, they've got there is calculate that 9 plus 17 minus 4 in parentheses and divide it by 4. So first of all, you just work your way from the inside of the parentheses there as you normally would work it out on paper. And that's what's great about the RPN system, is you kind of almost treat it like you would if you're working it out on paper. And so you take your first number, type in your first number 9, hit enter, so that pops it into the X register, and then you want to add 17 to it, so you go 17 and you tell it you want to add it, gives you your intermediate result, and then you tell it you want to subtract 4, so you type in 4 and you hit subtract, gives you your intermediate result of 22 there, and then you want to divide that 22 by 4, so you just hit 4 again and divide. So yeah, more complicated problems solved in the same way. So 6 plus 7, so 6, enter, 7, add them, and then you do, instead of doing the multiplication now as you're working across the equation, you actually do the 9 minus 3. So you do, so this is 13 stored here, and then you go 9, enter, 3, subtract, and you've got 6 there. But the 6 plus 7, the 13 is sitting up a level. It's actually sitting up in the Y register up here, if you imagine that, the Y register. And then so you want to multiply those two, you just hit multiply. And what it'll do is it'll take the what's in the X register and multiply it with what's in the Y register sitting above it. And you get your result. And so if you take the next equation there, and so you've basically got that equation where you've got 6 plus 7 inside the parentheses, multiplied by 4 plus 5, and then multiply the whole lot by 3, effectively is what that's saying. And so you start from the inner parentheses. And so to do this on a algebraic calculator will probably require the use of the memory command, whereas with the stack, use of the stack here, you don't have to use memory. So you do your 6 plus 7 first, 6 into 7, add that, gives you 13, and then you can multiply the whole lot by 5, in multiply, and then add your 4 plus, and then your 3 multiply, give you 207 answer. So yeah, it basically runs you through some scenarios there to, so you can practice. So there's also another register called last X. It's a register related to the memory stack. So you can recover previously used X registers. So for instance, that calculation at the top there where you've got 52.394706 repeated in that equation, you can use the last X to save you a whole lot of key presses. So basically you'd enter the 96.704, enter, and then you've got this convoluted number here, 52.394706, and you're adding the two, right? Adding, but then you're dividing it by that same number that you added. You can just recall last X, which is shift that one, and then just do the divide. And so saves you a whole lot of key presses. You could also store that 52.394706 in a register if you want to keep using it over and over and over. If it's a constant, basically, you could store it in memory. And there's plenty of memory locations, and that's sort of almost where it sort of gets into programming. But just showing the alpha keyboard, alpha entry. It's pretty straightforward. You just hit alpha, and this is your alpha register, and they're just giving a demonstration there, so you can literally just type in whatever you want, backspace, pretty straightforward sort of editing. You can use underscores. There is a helpful little reference on the back for some of the special characters. There's like your slashes and add, subtract in alpha. So it's kind of almost like a print. If you think of alpha as kind of being like what you would print inside parenthesis on a basic computer. So in basic, if you did print quote 1 plus 1 end quote, it's just going to print display 1 plus 1 as you see it. It would just display 1. I think I can do this, if you know what I mean. If you typed in that 1 plus 1 inside quotes in a print command and basic, that's pretty much what you'd get as a printout. And so this is similar. This is really just display. That's all the alpha register is doing, is displaying alpha characters. And but that will not add 1 and 1. It's just displaying it. So when you're out of the alpha mode, that's when you're back into the calculation mode there. You can execute commands. It's pretty cool. Continuous memory, basically, if you turn the calculator off, so we've got 4 in the X register. If I turn the calculator off and turn it back on, it doesn't forget anything. So this calculator's actually got programs stored in it as well, so it doesn't lose its memory when you turn it off. Bloody handy. The display. Basically just going through different notation types. Fix, I've shown you fix. So set to fix 4 at the moment. It's 4 decimal places. You see the 4 trailing zeros there after the decimal point. You've got scientific notation, engineering notation, low battery, errors, blah blah blah. Storing and recalling numbers. So this is really handy. So the base configuration for one of these calculators is 100 data storage registers, 0 through 99, directly accessible, and 219 uncommitted registers available in common pool for programs, alarms, and user-defined assignments. And you can change that partition to give you more data registers or fewer data registers, depending on what you want. So you've got memory limitations, of course. So it's showing us how to store and recall numbers. It'll give us some demonstration here. So if you take Avogadro's number, 6.02 times 10 to the power of 23. Pretty big. So first of all, you enter it, 6.02. The exponent 23. And then, so we've got a number. And if you want to store it, you hit store. And then it's prompting me for the storage register. If I want to store it in the very first register, I just hit 00. And that is now stored in that register. And if I multiply that number by 2. And then if I want to bring back the original number, I can just recall it from register 0. It gives me back the number. So that's a little bit like storing a variable in a way. Or if you're working with, like a computer, it's kind of like storing a value in a memory location and then doing some calculations, and then if you want to grab whatever's in that memory location again, you can just recall it. Pretty much, it's I'd say a reasonable analogy for that. If you want to clear all the registers, so you could have a whole bunch of data sitting in a whole bunch of registers, and if you just want to clear the lot, you execute the command execute clear register. So go alpha CL, what is it? CLRG, clear register. That will clear all the registers. And if I recall now 0, 0, it'll have nothing in it because it's just zeroed all the registers out. You can view the register contents, so if I store 10, store that in register 0, and then do the square root, and then if I view, shift view here, view storage register 0, we get 10. And so if I do multiply by 2, it doesn't actually multiply what's in storage register 0. It actually multiplies what's in the X register, which has disappeared. It hasn't disappeared, it's still there, but because I'm viewing register 0, 0, it's showing me what the contents of register 0, 0 is, but that X register is still there. So if I multiply by 2, it's multiplied that 3.1623 by 2, which was what was in the X register before I displayed the contents of the 0 register, or 0 memory location, I guess you call it. Yeah, actually they do call them register 0, 0. So exchanging X and Y registers, so that is used quite a bit, especially in programming. So basically it flips, so you've got your X register, that one, X register and Y register at the top. It basically just flips them. So if we do this 4, so 4, when I enter that, is in the X register. And it's a stack, as it says, it's a stack. So you've got the X at the bottom, Y, X, Y, Z, and then T register. It sounds a bit funny, but T is right at the top. So 4 is currently in the X register. And then so that's entered. And then I go 5. And if I do the X to Y command, which is a dedicated key, that one there, exchange X with Y. So currently 5 is sitting in the X register, and that 4, which I put in before, is bumped up to the X register when I hit enter. To the Y register. I'll do that again. So 4 is in the X register, I hit enter. The 4 now goes to the Y register, and the X register is basically duplicated what was in there before, so it's also 4. But if I hit 5, now 5 is in the X register and 4 is in the Y register, effectively above. And you can actually see that quite clearly if I use a different calculator. This has got a different display. This is the 19B2 Business Consultant, but it's also an RPN calculator. But it shows how the registers work quite well. Let's try changing that contrast there. So this will display it better. So you've got the X register right at the bottom there. So basically full of zeros. If I do the same thing, so 4, right, enter, you'll see 4 moves up to the Y register, and 4 is also sitting now in the X register. But as soon as I hit 5, you'll see now that 5 is in the X, 4 is in the Y. And if I do a X to Y command on this calculator, it's actually not a dedicated, it's a shifted key. So I'll do that. This key here. See, they have swapped. So now 4 is in X register, 5 is in the Y register. You can also exchange contents of a memory location. Not sure if this calculator works the same way with the memory, so I'm not sure I can demonstrate that. But if I put a 1 in here, now I've got 1 in the X register, 4 in the Y register, and 5 in the Z register. And if I do the add command now, basically what that's going to do is it's going to take the 1 that's in the X register and it's going to add it to what's in the Y register, the register above it. And so when I hit plus now, so to add these two together, actually, let's make, to make it a bit clearer, let's put 8 in the X register, and we've got 4 in the Y register and 5 in the Z. And so if I add, if I hit the add now, plus, it's going to add 8 and 4, and you'll see, what you'll see is you'll see that the 8 and 4 will be collapsed down to the result in X register, and the 5 sitting in the Z register will come down to the Y register, right? And so if I hit plus again, I can just add 12 and 5, and it'll just collapse them all down. And so it's really powerful, you know, for just doing calculations without having to use memory locations. It's bloody handy. And once you really get used to using an RPN calculator, it's really hard to go back because they're just so handy. So, you know, if you wanted to add 2 and 5, for instance, you can just go into 2 and 5 and just go plus 2 and 5, 7, and add it to 17, it's 24. So as long as you remember, you know, how this is laid out, you know, you'll understand how the calculator's working. And so you've got 4 registers, right? You've got the X here, it's got 2 in it, Y's got 8 in it, and Z's got 24. There's also T register, which sits above 24, which you won't see. It sits up here. So what will happen if I enter another number is 24 will move up into the T register, 8 will move into the Z register, 2 will move into the Y register, and then the new number is sitting in X, right? So if I just make the new number 5, I have to enter first, enter 5. So now that, was it 27, has gone off the display, but it's actually still sitting in the T register. And you can cycle through the registers too. There's this register roll down command, which the other calculator's got as well. And so if I do that, roll down, see 2's come down from the Y register into the X register, and 8's come down from Z into Y, and 24's come from T down into Z. And I can carry on rolling, right? So 5, that's what we originally had, so it's just going to roll through those 4. So that's quite handy. If you get your, if you input your data in the correct order, you can actually use that roll command to make the calculation really efficient. And you can also get more efficiencies out of that, doing that sort of thing in the programming side of things as well. So yeah, it's pretty powerful, pretty handy. But so that's basically, the crux of this here. So if I hit plus now, it's going to add 5 and 2. So whatever's in the X register gets added to the register above it, which is Y. And so 5 and 2 will collapse down to 7, and 8 will come down into the Y register like that. And then if I hit plus again, it will add 8 and 7, and it will collapse that down to 15. And then 24 is what was sitting in the T register. If I add that 15, it will collapse down as well. But you'll notice 24 is coming down, because as things collapse down, whatever's in the T register gets replicated down this downstream. And I can add, I can just keep adding, right? And it's going to add 24 forever now, because 24 is just filled up from the replication of the T register. It can take a little bit to get your head around, but once you sort of understand that that stack, it's really powerful. Really powerful. But this calculator here only displays one line, but underneath it all, it's still, the stack is still in use. So if I enter 1 has gone into Y register, 2 is in X, and if I enter that, it bumps up 2 into the Y, and what was in Y goes to Z. Into that, and if I fill all the registers and I do a roll down command, you can see all 4 registers have been populated basically. So if I so 1 was the first number I entered into X, then I entered 2, it bumped it up, entered 3, bumped it up, entered 4, bumped it up. So 4 registers, and I've just rolled them through. Okay, so if I add, so that's 4 and 1 added together, and then 5 and 3, and then add 1, or 2, sorry, and then it'll add 1. Well, it's doing 2 now constantly, yeah, because it's replicated what was in T register. Yeah. So as long as you remember that stack still exists, although you're only seeing one line, it makes it a lot easier to sort of comprehend how it's all working. So you can do arithmetic on what's in storage registers as well. It's pretty handy. So we have a perfect example here. Okay, so during a harvest, Silla's farmers trucks tomatoes to the cannery for 3 days. On Monday and Tuesday, he hauls 25 metric tons. I mean, all this can be done these days in a spreadsheet. It's kind of becomes moot in a way, but it is really quite nice to have a calculator sitting beside you that you can just, if you've got a calculation you do a lot, like I do a lot of like just adding GST or subtracting GST or doing like cost and sell prices and just working out the margin and all that sort of stuff. It's bloody handy just to have a calculator sitting right beside you, and you can program it to do all that stuff. And it's nice because you've got a dedicated thing sitting there. I mean, I've got crap all over the desk, and adding a calculator to the mess doesn't really make much difference, but I have this calculator sitting beside me all day, every day, and I use it heaps every day. It's just a lot easier than cranking up the calculator app on your phone or on the computer, and they're just a pleasure to use. And so you can use it for everyday stuff to this day. I mean, some of this here seems a bit dated, but you got to remember this is the 1980s, or I think late 70s. I think it's the late 70s. Dates on it, but yeah, it's around that era. Put it that way. It's But yeah, if anyone's coming to the this is dated March 1980. This manual, that one there. Beautiful manual. If anyone's coming to the meetup in Wellington at Easter, come and say hi and come and have a look at the real manual and things, because it's just a thing of beauty. And I mean, the paper and everything's just the top notch quality. It's just amazing, and it's just something that you kind of have to feel and see to actually really appreciate. But yeah, I'll be taking this stuff along. So this, and I've got devices that attach through the HP interface loop, and so you can hook up a tape drive to this to store programs on a tape. And it's not like old school bloody Spectrum tape where you have to queue up the tape recorder and make sure you've got it right to the end of the last program, otherwise you'll overwrite, your program, or you might have too much gap in between and all this. The tape player for this is intelligent, so you can save it, giving it a name. It's like a disk drive basically, except it's retrieving the information from tape. It's really cool. You can give the program a name and just hit save with the save command, store or whatever it is. I can't remember the exact command, and it saves that program to the tape. And you can save like 10 programs, and then you can just go, I just want to retrieve program A out of, A to Z, whatever. I want program A, and it just will find program A, just automatically rewind the tape or fast forward the tape, whatever it needs to do, and automatically play it. There's no play or fast forward or rewind buttons on the tape deck at all. It's really cool, and it's got a little I've got a printer, it's not infrared, it's a little thermal printer for it as well. So you can tell the printer to print just results, or you can tell it to print absolutely everything that you type into it, like a trace mode. You can use it for debugging and things like that. You can network these things together. There are RS-232 add-ons for them. I've got a RF add-on for it that is no longer working. It's actually got like video output. There's a little barcode wand reader thing for inputting programs, but I don't have one of those. There's a card reader that fits into the top of the unit. I'll probably cover that in another video. But yeah, there's a whole lot of add-ons for it. That's really cool. I've got 2 multimeters up. I've got 1 multimeter up here. I've actually got 2 of them, but one's up here. And I can communicate with the multimeter. And so you can do things like set a threshold. You can say, right, you can just set it to monitor. Say you're monitoring a voltage or something like that. And you might want to say, well, if the voltage drops below, I don't know, you choose a value, say 5 volts, you can get it to log that and like give it a time and date to say this multimeter detected that whatever the device was under test dropped below 5 volts, and timestamp it, print it, or store that information in a register for you to spit out later if you wanted to. You could just get it to say every time it drops below 5 volts, I want you to store the time, the date, and what the voltage was, and register 0, and then you can increment it, say just increment. And then when you're finished monitoring, you can just recall those registers one at a time if you want to manually, or you can write a little program to say, print register 0 through 100, and yeah. So it's powerful, especially with all the add-ons. It's great. It's neat to play around with. I had a battery testing program set up, and I had 2 multimeters. So I had one measuring voltage, one measuring current, and so I was just logging that the whole time. And so I was doing like battery capacity calculations to just test how much capacity a battery's got. And there are other ways you can do that. It's a lot easier, but I mean, it was just something that I had a wee play around with, and so you could calculate the capacity from there. It's pretty neat. So yeah, so some of these examples are sort of like, they seem antiquated and old school now, but you can apply this to any sort of, as I say, I use it a lot for business. I run my own business, and I do a lot of, I sell stuff, and so, I'm buying it at cost and selling it at retail. And so I can work out margins and things like that. And if I want to give someone a discount, I can kind of just work it out. And it's say, you can have it all in spreadsheets, but I just sort of do it ad hoc, really. So this example here is, so on Monday and Tuesday, he hauls 25 metric tons. For Monday and Tuesday, 27 tons, 19 tons, 23 tons, for which the cannery pays him 55 per metric ton. On Wednesday, the price rises to $57.50 per ton. The farmer ships loads of 26 tons and 28 tons. If the cannery deducts 2% of the price on Monday and Tuesday because of blight on the tomatoes, and deducts 3% of the price on Wednesday, what's the farmer's total net income? So you can, there's the procedure there for working that out. So you can use storage register arithmetic to deal with that. So if we have a look here, 25, 27, 19 and 23. So that's these figures here in parentheses. It's that 25, 27, 19 and 23. So you just add those. The 25, enter, 27, add it, 19, add it, 23, add it. And 4, and then you multiply that by 55. 55 multiply. And you store that result. So the earnings from these deliveries, that's the total of Monday's, Tuesday's deliveries, you store in register 0, 1. Store 0, 1. So that figure is now stored in register 1. And then you take your 2%, right? 2% calculates deductions for Monday and Tuesday's bad tomatoes. And so you take that deduction and you subtract it from what is stored in register 0, but not only do you do that, you store the result back into register 0, 1, sorry. So it's taking what's in 0, 1 and deducting this from it and restoring it in 0, 1. So if we do store minus 0, 1, and that stores that. And then Wednesday's delivery is 26 and 28. 26 enter 28, add them together. Earnings on Wednesday is 57.5. Multiply that. And store plus to 0, 1. So you're taking Monday, Tuesday, Wednesdays, which was in store 01, less the blight, you know, the 2% for the blight. And now we're adding Wednesday's deliveries. So store plus 0, 1. So it's like memory plus, memory minus and things like that, except you've got more than one memory location. You've got, take the 3% and remove that from store 01, so store minus 0, 1, and then you recall what's in 0, 1, and that's your result. So pretty handy for that sort of thing. I mean, I'd have to practice that on, if I was to do that on an algebraic calculator using memory plus, memory minus, things like that. I'd really have to practice that one. I'm sure it's reasonably easy to do, but if you start dealing with more than one register, memory register, where this comes in really handy. So this is like executing commands. So here it's calculating the factorial of 6. So if we input 6 and then just execute, and because the command has a name as such, go to alpha, and the command's called fact, as in for factorial, fact. Hit alpha, and as soon as I hit alpha, it's kind of like hitting enter. It's completing the alpha input, and so the computer will execute that. Give us the result. You can redefine the keys on the keyboard using the assign function. So if you've got a program that you use or a command like that, factorial, that you use a lot, you can actually dedicate a key to it. It's also bloody handy. So if I want to assign factorial to this key here, you can choose the assign command there, assign, tell it what you want to assign, F-A-C-T, and then it's asking basically what key, so that one there, 1, 1, so that is row 1, column 1. And then if I go to, so any of these commands, if you press and hold them, they will actually show you what they are. So if I do like square root, right, if I hold that, you can see it says square root. If you hold it for a long time, well, longish, it just nulls it. It doesn't execute it. If you just want to see what it is, you just hold it. If I tap it, it's going to execute it. So that, you can see there. But if I do, so I've assigned factorial to that key, but you can see it hasn't actually assigned it on this keyboard here yet until I hit user. So if I hit user, you'll see that because I programmed that key, if I hold it down now, it's factorial. And all the other non-programmed keys here are just default. Oh no, that's actually a program I've put in there. So is that. Yeah, so I've actually got quite a few user commands on this keyboard here already. But the likes of that store, yeah, it's just going to try and execute it. But change sign, if I hold change sign. So any key that I haven't already assigned just remains default. But if I hop out of user mode, you can see that it's the default key. Viewing assigns. Okay. So this sort of gets into general maths functions, nothing too exciting. Arithmetic, trigonometry, converting between degrees and radians, all that sort of stuff. Electronics, bit of Ohm's law. Statistics, so there's a whole lot of nitty gritty. Mean, vectors, time, so you can set the time, which I haven't done on this one, and so clock will display, we did that before. Date format, setting the date. So if I execute the command set date, execute alpha set date alpha. You got to put the information into the X register first. So May, so let's say it's March dot, it is the I wonder if it's year 2K compatible. 26th. So 26th of March So 1992. Oh yeah, so 2199 is valid. So 199 I'm assuming is 1990, is it? Yeah, it is too. So 2025 and then execute alpha set date. Doesn't like it. Unless maybe I should set the date format to day, month, year. So I think that's execute DMY, I think is all that I have to do there, I think. It's been a while since I've really used this in anger, this apart from just calculations. DMY, so maybe it didn't like that data. 3.2625 execute set date. Doesn't like it. I'll just look at what the date is. So I think that's the 10th of June 1901, I think is what that's. It should work. V dot I wonder 03 dot 26 2025 execute it date. Emit zeros 3.2620. If I do 202, then that's implying 2020. I've never had trouble with this before. Oh, because of course I'm in day, month, year. Oh, doofus. What? I don't know what I'm doing wrong there. I might have to skip that and just work that out later, because let's see what time it thinks it is. 10:33, 57 PM. I'll set that to 24-hour time. Clock 24. CLK 24. U234. So if I do 21.37, execute set time, set it accepted that. 21:37 roughly, yeah. Yeah, not sure what's going on with that date one. I'll work that out at some stage. Yeah, so there's calendar functions. So you can calculate the number of days between two dates and finding the day of a week. So you can find what day of the week you were born and all that sort of stuff. It's got alarms and setting alarms. I don't use the alarm. So the basic model, the HP41C, doesn't come with all these time functions. You had to buy an add-on cartridge for that, like these here. These little cartridges here. So this one I've got extended I/O, which gives me exactly that, extended input-output. For use with the HP interface loop, and so you've got 4 ports on the back here, and you can plug in a card reader and things like that into here as well. So there's a time module, and there's all sorts of different modules. You get maths ones, navigation, structural, all sorts of engineering stuff. Games even. So they come in these boxes here. There's like games pack. You get like a little manual for it. I haven't played some of these. Hangman, guessing games and stuff. Space War. Should have a wee. I reckon we should have a wee play with these at some stage. Submarine Hunt. So yeah, they basically just plug in, and you get these little overlays that go over the keyboard. So these little overlays that come for each of the games, and they so the game will assign keys, you know, so you basically just pop those in there like that, and you've got your different commands there. So yeah, pretty handy, pretty cool. Accessories catalog. Aviation, there's an aviation pack. Any aviators out there watching? Totally obsolete now, I'm sure, but position and navigation by 1 or 2 VORs. Winds, flight plans, all sorts. Yeah, so lots of formulas and goodies. Yeah, I don't understand any of that, but yeah, there's all sorts of different. Ooh, what have we got here? It's a gift. Christmas gift exchange card, dated 1983, for a cash refund from Whitcoulls. For the application pack. So someone got an application pack for Christmas for their HP 41. We've got a receipt. Oh, that's someone playing a game, and it's printing out as it goes. Business card. This looks like something that they can just pop through like a punch card reader or something, eh? Or like a feed it into a computer and it reads whatever you've chosen, I guess. Pretty cool. Yeah, there's a whole bunch of those applications. It's for pre-flight use only. I think I'll finish up with the calculator for tonight. It's the basics. We've covered sort of the basics with it. Yeah, Might come back and do a bit more with it at some stage, but that just gives you a bit of an idea of how it all works. And one of the calculators I'll be taking along to the show, so yeah, along with some of the peripherals and things like that. I've been thinking about what else I'll take along with me. Probably some more HP calculators. I've got some other models that are quite neat with card readers built in and things like that, like mini computers, QWERTY keyboards and things like that. And yeah, probably might take some Casios along maybe, and maybe other handheld devices. It really depends how much I can pack into my case. Might take, like, if I can fit it, maybe my Atari Lynxes with some games, and I've got a Tandy little, what is it, TRS, like a portable TRS 80 type thing. Can't remember what it's called now. And yeah, maybe some of those handheld things that are just nice and easy to transport. Chuck them in the suitcase and take them over to Wellington with me. Going over on the plane, so as long as I'm under my weight limit, I should be fine. I've got a suitcase and all that organised, so yeah, just starting to sort of put together what I'm going to take really. So I thought I'd just give you a quick rundown on the old HP41 just to start with. Anyway, we can do some more advanced stuff with it later on, maybe show you a bit of programming and things like that. It's pretty cool. But yeah, I wonder if I might just crank up some Half-Life 2 for the rest of the evening, but I'm just going to have a quick break, so I'll pop back and we'll get into some Half-Life 2.
Remember to roll and land, alright, buddy?
Yeah.
That's the boy. Dinner ready, honey?
Now, with over 200 games, there's only time for the important things in life.
Microsoft, ready to play. From the co-designer of the hit title Civilization comes Age of Empires. From the Stone Age to the Iron Age, experience 10,000 years of amazing discoveries as you build your tribe into a great civilization. Will you explore new lands, amass great riches, or conquer all in your path? You choose your favorite form of world domination. Age of Empires.
Are you keeping up with the Commodore? 'Cause the Commodore